All right, I want to start in this video by talking about your linear versus exponential assignment, which is due before the start of class on Thursday. On Wednesday, that is your only thing to finish working on that and finish that up. So here's from the sheet that you have for the linear versus exponential. So again, you're assuming that you have a friend from class, they've been absent for a while. And basically we want to get them caught up on the differences between linear and exponential growth. So the idea is that it should be a page or two talking about the key features, similarities, differences between linear and exponential growth. Does not have to be typed. You can do it handwritten, but just make sure it's neat when you're doing it. So let's just kind of make a bullet list of what you need to make sure you have for each. So for each of them, you've got to show an example graph of a linear function and an exponential function. Make sure you have an example table for each. And you should have an example equation for each of them. Now with the equations, tell what each of the different parts of the equation are. So some things that we didn't know before these last few units that you should be sure to include. Think about that discussion post we made right before break. In our linear function, we knew our slope was constant. And you should show how to get that, because that's a key part of your equation. For the exponential, the big thing was our successive ratio. So you should make sure you talk about that and show how to get that. Now, when you're doing your equations, make sure to show how you can get those equations from your table. That's a big thing that we've learned. So if you have a table of data, how can you write what the equation is from that table of data? So those things you want to make sure you have, make sure you describe how to find them. Successive ratio is a huge thing. That's a term that no one had heard before the last unit. So if you don't include that in it, that's going to be big points that you would lose. You got to make sure you talk about that, talk about how to find it, make sure you're talking about how to find the slope in a linear function, where that would go in the equation, things like that. So that's basically the stuff that you need to make sure you include. It would help someone get caught up if they've been out for the last few weeks. So again, that's what you'll be working on for homework on tonight, for your assignment for tomorrow, and then it needs to be uploaded before class on Thursday. So what you're going to be working on in class today is a continuation of our M&M experiments. At this time, the hope is that for both of them, you have collected your data with your M&Ms, and you've also done the graphs. So basically, in both of our experiments, you're up to there. Now, one of the tricky things for these is there's lots of different things it asks for. So we're going to go through and we're going to number each of those things, and I'd like you to number them in your packet too to make sure you don't miss out on them. You're going to be doing all of your work on a separate sheet of paper. So first we want to write an equation that can be used to predict the number of M&Ms. So let's number that 1. Explain the meaning of the coefficients and variables in your equation. So that's something you got to do. What would be a reasonable domain and range for your function? So let's put a 3 there. Estimate the average rate of change of M&Ms in the cup at the 8th trial. So that's 4. So rate of change, remember that is our slope. And we should be using our 0.01s like we did in our bacteria growth when we found our rates. Now note, you need to make sure you have units on your answer for that. Number 5, the number of M&Ms in trial 15, number 6, trial number 20, and then 7, how many trials would be needed for 3 M&Ms. So there's 7 pieces of information that you're going to do for that one. If we look at experiment 2, again, hopefully you're up past that point right there. Hopefully you've created a graph by this point. So first thing, we want to write an equation that can be used. Remember, just like any other equation, make sure to tell what x and y represent once you write it. Explain the meaning of the coefficients and variables. What would be a reasonable domain and range? That's the third thing you got to do. Estimate the average rate of change, this time at the 4th trial. So notice a lot of the stuff is pretty similar to what we're doing in the first one. Make sure you include units on it. 5th thing, how many M&Ms would be in the cup at the -2 trial? So imagine you could go backwards with your trials. We're figuring out how many M&Ms would be there. Number 6, how many are there, or how many trials when there would be 900 M&Ms? And if we started with 500 M&Ms, how many trials would it take until you had 4 or fewer M&Ms? So that's 7. So you should be able to make an adjustment in your equation for that to make it be as if you had started with 500 M&Ms, and then it's pretty similar to question 6 then. So there's 7 things you'll be doing for that one. So the goal is for today's class is to finish experiment 1 and be started on some of the questions for experiment 2. At the end of the class period on Thursday, you will be expected to upload all of your work and answers from experiment 2, and that will be graded for correctness. Now, I want to go back to experiment 1 for a second, and let's just talk about how to find our equation. So I'm going to come up with a hypothetical data table that you had. So this won't match yours exactly, but we had trials and we had M&Ms. On trial 0, everyone had 3 M&Ms. So let's say at 1 we had 4, at 2 we had 6. Let's say at 3 we had 9, at 4 let's say we had 13, and at 5 we had 20. Okay, and you kept going until you either ran out of M&Ms or hit trial 10. But just for the sake of showing you what to do here, we'll work with this. So one thing to note is it's not going up by the same number of M&Ms every time. And hopefully you recognize this when you graphed it too, is that it looks exponential. So we're going to be in the form y equals a times b to the x. So our starting value should be that 3 M&Ms. So we're going to have y equals 3 times something to the x. Well, to find that something, we're going to do our successive ratios. But the problem is because this was an experiment, the successive ratio is not going to be perfectly constant like it should be in an exponential. So here's what we're going to do for that. We're going to find each pair of successive ratios, and then we're just going to average them to the nearest hundredth. So we always do y2 divided by y1. So this will be 4 over 3. This will be 6 over 4. This will be 9 over 6. 13 over 9. And the last one will be 20 over 13. So then what I'm going to do is I'll add those up. And I'll divide by how many are there. Now, one of the things we need to be careful about when we're adding those up is your answer initially is going to be a fraction. And we said we're going to round our b value to the nearest hundredth. Like when I added those up, I got 856,117. So I need to now divide this. There's 1, 2, 3, 4, 5. When you take an average, you divide by how many are there. So notice I'm dividing by how many successive ratios are there. There's 5 successive ratios, so I'm going to divide that by 5. And that gives me 856 over 585. But we said we wanted that as a decimal to the nearest hundredth. So what you need to be careful about is don't just hit Control Enter, because that'll read divide by 5. You have to scroll up, highlight the fraction, hit Enter to bring it down, and then hit Control Enter. And for that, I got 1.46. So my B value that I would use is 1.46. And then I would make sure to tell that X is the trials and Y is the M&Ms. Now, when you get to this for experiment 2, keep in mind we went all the way down to 0 eventually. So when you do your successive ratios, normally an exponential function doesn't go down to 0. So what I want you to do is on experiment 2, don't include that last successive ratio, because the 0 is going to throw our value off quite a bit. So don't include, when you get to experiment 2, don't include that last successive ratio in your average, because the fact that ours went to 0 in our experiment and a real exponential function doesn't go down to 0, that will throw your values off some. And we'll mention that in Thursday's video just as a reminder. So goal again for today is to at least get through the questions for experiment 1, hopefully be able to start experiment 2 as well. And remember, you're doing this all on a separate sheet of paper.